Welcome to Module 15 on graphing quadratics. Right now, get your notebook out so that you can take notes. Don't forget, you're going to want to be able to use your notes on your quizzes and on your tests, so it's a good idea to take good notes and label them appropriately. So on that note, let's turn to a new page and write Module 15, Graphing Quadratics. You do not have to write all the agenda items, just write the title. In order to graph a quadratic, we're going to want to be able to find some features of a parabola. We want to be able to find the vertex, the intercepts, the axis of symmetry. We're going to be able to calculate the zeros, and we're going to talk about what maximum or minimum means in terms of a quadratic. So we're going to start with features of a parabola. So would you please start a new topic in your notebook, features of a parabola, because you're going to have some notes to take along with this. So the first question asks, does the parabola open upward or downward? So if you look at your graph, there are two options. Upward is what we call either up like a cup. Downward means down like a frown. In this case, this one is down like a frown, so it opens downward. The axis of symmetry is the middle of the parabola. So in this case, it's right here. A vertical line is always going to be x equals. So our axis of symmetry is always x equals some number. In this case, that's in between -2 and -4. So x equals -3. The vertex is somewhere on that axis of symmetry, which means that the point is -3 straight from our x value, comma. The vertex is either our maximum or our minimum point. In this case, it's a maximum point. It's the top point. It's the point where if we were treating this like a roller coaster, you would stop from going up or down, and you'd have that pause where it feels like you're sitting at the top, and then you go down the other side. So the vertex on this is -3, 1. The intercepts are what we also call the zeros. You should write that down. When you find the x-intercepts, you are finding the zeros, you're finding the points where it crosses the x-axis. So our zeros for this are -2 and -4. Oops, we don't need a parentheses. That's not the point, -2, -4. It's two separate points. The y-intercept is where the line crosses the y-axis, and in this case, it would be at -8. You pause the video, see if you can fill this one in all on your own. So the direction says up like a cup. The vertex is right here. It's the point, let's see, 3, 0. Since the parabola opens up like a cup, that means our vertex is a minimum. For the x-intercepts, this just crosses the x-axis at 3, and the y-intercept is 8. The axis of symmetry cuts through the middle of the parabola, so you should have said that x equals 3. And that's it for that one. Now, let's talk about how to actually calculate the zeros. So you need a new topic, write finding the zeros and underlining it. The zeros of a function are just the x-intercepts. So I want you to write that down. The zeros of a function are just the x-intercepts. You can find the intercepts by factoring or using the quadratic formula. It's up to you. I usually like to factor, so I'm going to multiply a times c. So -12 times 1 is -12. I'm looking for two numbers that multiply to be -12 and add to be -11. So 1 and 12, that might work because 1 times 12 is 12. If I made the 12 a negative, then that would become -12 times 1, which is -12, and -12 plus 1, which is -11. So I've got my magic numbers. I'm going to rewrite this as 1x squared minus 12x plus 1x minus 12. I'm going to separate this into two groups, the first group and the second group. The GCF of the first group is x. If I factor that out, x squared divided by x is x. -12x divided by x is -12. There is no GCF for 1x and -12s, but we always have to use something, so we use 1. That means this just stays the same. These match as they should, so that's one of my factors, and this is the other one of my factors. Remember, the zeros are where the y value is equal to 0, so we're going to replace y with 0. We're going to make x minus 12 equal to 0 and x plus 1 equal to 0. Add 12 to both sides, so our x-intercepts are 12, and subtract 1 from both sides, so our x-intercepts is negative 1. We have 2. It crosses the x-axis at 2 places, 12 and negative 1. So essentially, I replaced y with 0, and then I factored and set both factors equal to 0 using the zero product property to solve. You pause the video and try this one on your own. If you're using factoring, you're going to multiply a times c. So we're looking for two numbers that multiply to be negative 15 and add to be 2. So I'm looking for two numbers that have a difference of 2. So 1 and 15 will not do it, but 3 and 5 might. I need one of these to be negative, but I need the 2 to be positive, so that must mean the 3 is negative. I'm going to go ahead and factor this. 1x squared plus 15. I'm replacing b with the negative 3x and the 5x. So it's 1x squared minus 3x plus 5x minus 15. I'm going to factor the first group and factor the second group. The GCF of the first group is x. That leaves me with x minus 3. The GCF of the second group is 5. That leaves me with x minus 3. These match as they should, so that becomes x minus 3 times x plus 5. And we need that to equal 0 to find the zeros. X minus 3 equals 0, so x either equals 3 or x equals negative 5. If it ever is not factorable, if you ever run into something that's not factorable, you can't find the magic numbers, this doesn't work, then you'll need to use your quadratic formula. And we'll practice that at least one time later on today. Now, new topic, writing an equation given the zeros. To write an equation given the zeros, just follow the steps of factoring in reverse. So it says write a quadratic function whose zeros are 6 and 5. So essentially we're starting with our answers, x equals 6 and x equals 5. Remember, I wanted these to be equal to 0, so I'm going to subtract 6 from each side, subtract 5 from each side. That gives me x minus 6 equals 0 and x minus 5 equals 0. These are now my two factors. So I'm writing x minus 6 times x minus 5 equals 0. Remember how we split those up into 2 to use the zero product property? Now we're just doing that process in reverse. Now we use our distributive property, both of these times x minus 5. So x times x minus 5 minus 6 times x minus 5 equals 0. This becomes x squared minus 5x minus 6x plus 30 equals 0. And this, to simplify the like terms, x squared minus 11x plus 30 equals 0. And then you don't want this to be 0, you want it to be equal to h because they asked you to write that as a quadratic function h. You pause the video and try this one on your own. You should have set both 1 and negative 9 equal to x, and then these are the zeros, so you want to subtract and add from each side. So you should have gotten x minus 1 equals 0 and x plus 9 equals 0. These are now your two factors. So we're going to multiply them. So x minus 1 times x plus 9 should equal 0 because of our zero product property. Now we just distribute x times x plus 9 and negative 1 times x plus 9. I'm just doing both of these things times x plus 9. Now I distribute x squared plus 9x minus 1x minus 9 equals 0. Combine your like terms, so that's x squared plus 8x minus 9, and they want it to be equal to f, so I make that equal to f. I want you to notice all this is just factoring in reverse. This is your factoring in, this is your zero product property in reverse. So if I'd started with this, I would have found my magic numbers. I would have factored by group. I would have factored out an x and factored out a negative 1. I would have had these matching. The matching ones would have come out. I would have been left with x minus 1. Then I would have split these into 2 and solved to get my two zeros. It's just factoring and solving all in reverse. That's it. Now, what if there's just one zero? What if h is equal to negative 12? Well, I still need this to be a quadratic equation. Actually, that should be an x, I'm sorry. I still need this to be a quadratic equation, so I'm going to make both of these equal to 12. I'm going to add 12 to each side, so we have x plus 12 equals 0 and x plus 12 equals 0. All this means is that the two factors are the same. We still have to multiply them together because this is a quadratic equation. I'm doing each of these terms times x plus 12, so x times x plus 12, plus 12 times x plus 12. I'm going to distribute. X times x is x squared, 12 times x is 12x, 12 times x is 12x, 12 times 12 is 144. Combine your like terms, x squared plus 24x plus 144, and they want this to be a quadratic function h. And that's it. You pause the video and try this one on your own. You should have made both of your zeros equal to -2. You need these to be equal to 0, so we add 2 to each side to make that happen. So now I have x plus 2 equals 0 and x plus 2 equals 0. These are my two factors now, so I'm squaring x plus 2, so it's x plus 2 times x plus 2. And then both of these things need to be multiplied times x plus 2, so it's x times x plus 2, plus 2 times x plus 2. We distribute. X times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4. Combine your like terms, so it's x squared plus 4x plus 4, and they want that to equal h. And that's it. Now, finding the max or the min. So new topic, I want you to write finding the max or the min, the vertex. And you're going to want to take some notes on this. When a problem asks you to find the maximum or the minimum, they're asking you to find the vertex. So in your notes, you should write something like max or min equals the vertex. And then you're going to want to write down, you want to start by finding the axis of symmetry using the formula x equals -b over 2a. And then to find the max or min value, substitute x into the equation and find y. You should pause the video now and make sure you've written down all the things that I've marked. All right, so the first question asks, does the function have a maximum or a minimum value? Well, remember, it's either up like a cup, so it looks like this, or down like a frown, so it looks like this. If it's up like a cup, then you have a minimum. If it's down like a frown, then you have a maximum, the top point. So you should write this down probably and draw yourself a picture. If a is equal to a positive number, you know this is up like a cup. If a is equal to a negative number, not -1 necessarily, just a negative number, then you know this is down like a frown. So let's look at this. A is equal to -1. If a is equal to -1, that means it's down like a frown, which means it has a top point, so it must have a maximum. To find that maximum value, I use x equals -b over 2a. Well, b is b is 2, so that becomes -2 over 2 times -1. Remember, this is a, b, and c. So that's -2 divided by -2, which is +1. That gives me my x value. The maximum or minimum value occurs where x is 1. To find the maximum or minimum value, I need to substitute in to the function. So this becomes -1 times 1 squared plus 2 times 1 minus 4. I'm substituting x into the equation. Remember, I'm using my function here. 1 squared is 1. -1 times 1 is -1. 2 times 1 is 2, and then we bring down the minus 4. Now we add and subtract in order from left to right. -1 plus 2 is 1. 1 minus 4 is -3. So the maximum value is at -3. Make sure you've written down all these notes because you're not going to be able to memorize all these right away, and then you're going to get to the homework and have no idea what to do. So make sure that you've written all this down. And then let's try this one all on our own. Welcome back. You should have first looked at, does the function have a maximum or a minimum value? You're looking at a. A is equal to -3, which means this is down like a frown, which means it looks like this, which means it has a maximum point. I can't find the maximum or the minimum value until I find this. So x equals -b over 2a. Remember, this is a, b, and c. b is 12, but there's a negative there, so that's negative 12 over 2 times negative 3. That's negative 12 over negative 6, which becomes positive 2. So the minimum or maximum value occurs at 2, and then I need to substitute in. So this becomes negative 3 times 2 squared plus 12 times 2 minus 14. Make sure you understand your order of operations. Exponents come before multiplication. So 2 squared is 4, and then negative 3 times 4 is negative 12. 12 times 2 is 24, and we bring down the minus 14. Negative 12 plus 24 is 12, and 12 minus 14 is negative 2. So the function's maximum or minimum value occurs at negative 2. Make sure you've written all this down before we move on. All right, so now, new topic, finding the x-intercepts and the vertex. You're going to want to write these notes down to yourself. You don't have to write every word, but you should write like something like x-intercepts colon factor or use the quadratic formula. Axis of symmetry colon x equals negative b over 2a. Vertex, substitute in the x and solve for y. Make sure you've got all that down before we move on. So this says to find the x-intercepts first. So that's either factoring or quadratic formula. I'm going to use quadratic formula since we've already used the factoring method today. So for the quadratic formula on this problem, a is negative 1, b is negative 4, and c is 12. The quadratic formula is negative b, so it's negative negative 4, plus or minus the square root of b squared, which is 16, plus negative 4 times a times c, all over 2 times a. All right, let's clean this up. A negative negative 4 becomes a positive 4. This becomes 16. Negative 4 times negative 1 is positive 4, times 12 is 48, so this becomes 16 plus 48 divided by negative 2. I'm going to simplify what's in the square root first, so this becomes 4 plus or minus the square root of 16 plus 48, which is 64, all over negative 2. The square root of 64 is 8, so it's 4 plus or minus 8 all over negative 2. Now I'm going to split this up into two problems to find the zeros. 4 plus 8 divided by negative 2 becomes 12 divided by negative 2, which is negative 6. And 4 minus 8 divided by negative 2, so 4 minus 8 is negative 4, divided by negative 2, which is positive 2. So your zeros, the x-intercepts, so our x-intercepts, so far we found are negative 6 and 2. But it also asks for the vertex. For the vertex, it's x equals negative b over 2a. This becomes negative negative 4 because b is negative over 2 times negative 1. Negative negative 4 becomes positive 4. 2 times negative 1 becomes negative 2. 4 divided by negative 2 is negative 2. Now I'm going to substitute into my equation. So y equals, see it says substitute in the x you found for the axis of symmetry and solve for y. So it becomes negative times negative 2 squared minus 4 times negative 2. Be careful with your order of operations. Negative 2 squared is 4, but there's also a negative on the outside of the parentheses, so that's negative 4. Negative 4 times negative 2 is positive 8, and then we're adding 12. Negative 4 plus 8 is 4, and 4 plus 12 is 16. So my axis of symmetry was negative 2, but my vertex is a point. My vertex is the point negative 2, comma 16. So that came from there and there. None of this information is new to you. These are all things we've done before. The zeros were found using the quadratic formula. The axis of symmetry we already learned today. That's x equals negative b over 2a. The only thing that's really new here is substituting into the equation to get y. You pause the video and try this one on your own. All right, you should have started with finding your x-intercepts. So for this, a is negative 1, b is negative 10, and c is negative 25. I'm going to see if I can factor here. So negative 25 times negative 1 is positive 25. I'm looking for two numbers that multiply to be 25 and add to be negative 10, and those numbers are negative 5 and negative 5. you use quadratic formula, you'll end up with the same problem that I will, so don't worry. If I'm going to factor, this is negative x squared minus 5x minus 5x minus 25. I'm grouping my first two with my second two. Notice how I put that negative inside the parentheses. These have in common a negative x, so if I take out a negative x, that leaves me with x plus 5. If I take out a negative 5 here, that also leaves me with x plus 5. So my two factors are negative x minus 5 and x plus 5 equals 0. Negative x minus 5 has to equal 0, and x plus 5 has to equal 0. This becomes negative x equals 5, which means x equals negative 5. This one also means x equals negative 5. So you just have one x-intercept here. The x-intercept is x equals negative 5. For the axis of symmetry, which I know it doesn't ask for, but you need that to find the vertex, we're using x equals negative b over 2a. That's negative negative 10 over 2 times negative 1. Negative negative 10 is positive 10. 2 times negative 1 is negative 2. And 10 divided by negative 2 is negative 5. This becomes x equals negative 5, so we're substituting in to find the vertex now. We substitute into our equation y equals negative 5 squared minus 10 times negative 5 minus 25. A negative times a negative is a positive, so just that becomes positive 25, but there's a negative on the front. A negative times a negative is a positive, so that's plus 50, and then we bring down the minus 25. Negative 25 plus 50 is positive 25, minus positive 25 is 0. So my vertex, after all that work, is just negative 5, comma 0. All right, we're going to pause the video here. I want you to go take a 5-minute break, get a drink, get a snack, and then we'll go on to graphing a parabola.